Okay, so today's topic is Kirchhoff's law, Kirchhoff's rules. Uh, which you can see from my presentation. So what we'll do, we'll just learn what are the Kirchhoff's rules and related things, and we'll try to uh, solve some problems using Kirchhoff's rule in today's class. So far we have learned combination of cells, combination of capacitors, combination of resistors, everything we have learned. Okay, but those rules of combinations of various circuits like resistors and all those things, it is easy to calculate using the combination rule, combination of resistors, capacitors, and etc. They are helpful as long as circuit is simple circuit. But if the circuit is very complex, then it is not possible to use the same combination rules to find out the potential drop across certain part of the circuit or current through any branch of the circuit. Okay, so before we learn Kirchhoff's law, Kirchhoff's rules are also told Kirchhoff's law. So before we go to these laws, we have some basic things to understand, some points to understand about electric circuits. Like, say, if I tell you junction, what is junction of a circuit? Junction of a circuit, if I draw a circuit, suppose this is resistor, this is another a battery, and then this is another battery, okay, another resistor, like this, and then I draw another resistor over here. Okay, maybe I'll just draw it. Okay, another battery suppose, and then a resistor over here. So see the points where, so this, suppose this is A, this is B, this is A and B points. These points, you look here, see currents coming to this, okay, or maybe, yeah, so here this is also battery. So at these points, actually you can look, the currents are coming into and going out, like that it is happening. So junction means where many branches are coming and meeting together. Branch means what? Branch means this one is a branch, this one is a branch. So ABA branch, if I write this is C and D, CD is another branch of the circuit. Okay, it can be even much more complicated. Okay, it can be a, see, if I draw simply like this, okay, so this can be also a junction. Okay, this can be told as junction. Okay, this is junction of the circuit. So this is junction of the circuit. Now we'll learn branch of a circuit. I had already told somewhat branch. So branch means, suppose I have this, like this, then you have suppose this. So this can be connected to a battery like this, to another resistor maybe. So this can be, okay, I'll just, there can be another battery, okay, maybe another resistor over here, then it can be connected like this. Okay, so see, if I give some name, suppose this is A, this is B, this is C, this is D, this is E, then this is F. So if I give some names like this, see, these are one branch. Suppose this is another name, maybe G. So this BG one branch. Okay, I can write. Okay, I have CDE. Suppose this is G, this is H. Okay, so GH or maybe GD is a complete branch, you can say. Okay, this is BH is another branch. So like that, I can have a single path. Okay, a complete path is called a branch actually. See, before I go to another junction, it is called a branch. Okay, so even you can see, if I just look this loop. Okay, so this is a branch, this is a branch. So branch of a circuit is actually path path before it reaches to next junction. Uh, Guna madam, can you switch off, mute yourself because it is too much noisy. Yes. So branch is actually the path of the circuit before, like in between two junctions. If I say G and D is a junction, so you can look this whole, so GD, so this is whole branch. Okay, so this is one junction, this is another junction. GH is one junction, another junction is this one. So I can say this is BG is a branch. Okay, so here you look, this is a junction. So this is another branch, I can say GF, then ED, up to this is another branch. So branch is a part of the circuit between two junctions. Okay, then I can learn about loop. These are actually common terminology which will be coming across while learning this Kirchhoff's law or applying in various problems. So loop, what do you mean by loop? Okay, so I had some figures here. See, loop means so if I start from here, suppose D, E, F, or maybe I can start from C, D, E, F, and then C. So this is a complete loop. Okay, this is a complete loop. So I can start from C to D, D to E, E to F to C. So this is a complete loop of the circuit. Again, I can show you another loop. So this is a loop, and this is C, F, or maybe I'll go from here A to B to C, then F, A. This is another loop. So there are two loops over here. So this is how you can identify various loops in the circuits. So you might be thinking why you are teaching this kind of things before you teach the Kirchhoff's law. You will understand why I have taught you this thing, because we have rules, Kirchhoff's rules. There are two rules actually. The first rule is called junction rule. Junction rule. Okay, junction rule. What this rule is saying, this according to this junction rule of Kirchhoff's junction rule, it is saying that the amount of current entering a junction is equal to the current leaving that junction. So if I just draw, suppose this is a point, suppose here many currents are coming. Okay, so this is a junction. Okay, this is a junction. So you can take another resistors. Okay, sure. You can connect to this junction like this. Okay, suppose at this junction various currents are entering, like I1, this is I2, sorry, I2, and this is suppose I3. So these are the currents entering to this junction. Okay, and leaving this junction is actually currents are leaving. This one is I4 and this is I5. I5 which are leaving this junction. So according to Kirchhoff's law, the sum of the currents entering will be equal to the sum of the current leaving. That means I1 plus I2 plus I3, they are entering. So this is the sum of the currents entering. So this will be equal to I4 plus I5. So this is Kirchhoff's junction law. Okay. So you might be thinking, sir, this I understood. I understood the law, but on what basis this law has been proposed? On which basis? Suppose this this junction, through this junction, a steady current is flowing. A steady current is flowing. If a steady current is flowing, that means always at any time you take, the amount of the current flowing through this junction is same. That is called steady current. That is not changing. Current is not changing with time. That is steady current. So look, if this is steady current, according to conservation of charge, see, current means flow of charge. Okay, flow of charges. So through this path, whatever charges are coming to this junction, through this path, another path I2, whatever charges are coming to this point, even through I3, whatever charges are coming to this point, there, if you just put together all the charges, because it is a steady current, those charges will be actually flowing out always. Whatever coming in, they have to flow out. There will be no accumulation of charges according to, so accumulation of charges, no accumulation of charges. So charge has to flow because it is a steady current. So that's why according to conservation of charge, because see, this junction is not creating or neither it is destroying any charge. So whatever charge is entering into that, that has to flow out. Otherwise there will be accumulation. If there is accumulation, then your steady current condition, this condition will not be satisfied. Okay. And actually in any circuit, charges always flow. They never uh, get accumulated. They never get accumulated. Okay, at any point or any junction of the circuit. So because of this, so this is actually based on conservation of charges. So this is based on conservation of charges. Conservation of charge. So this has a basis. It is not an ad hoc proposal. Okay, this is not an ad hoc proposal that whatever current entering into a junction, if you take the sum, and whatever current leaving the junction, if you take the sum, both are equal to each other. So this is not an ad hoc assumption or ad hoc proposal. It is coming from the basis of conservation of charge. Okay, so this is actually junction rule. Okay, this is junction rule. Okay, I'll just discuss the loop rule also at the same time, and then I'll take up examples. Then you will be able to appreciate and you will be able to solve many problems with these rules. So let us take the other rule. So this junction rule deals with the current, right? So that's why the junction rule is also known as KCL, Kirchhoff's current law. Okay, KCL, Kirchhoff's current law. Because in the junction rule, or then the first rule, we just deal with current. That's why it is called Kirchhoff's current law. Okay. The second law is actually, or second rule is loop rule. Loop rule. So as I showed, uh, the loop, maybe you can think of. So this can be, suppose this is E1, this is E2, battery EMF. This is R1, R2. So this is a complete loop. Okay, this is a complete loop. So now in this case, what loop rule is saying, for a closed loop, change in voltage or potential, maybe potential I will write, change in potential is 0 for any closed loop. Okay, closed loop, any closed loop. Change in potential is 0. So if we write in terms of mathematics, suppose this is since this is a circuit, this is all are in series. So if I think that I current is flowing through this, so obviously so for the circuit will be I. So okay, so in this, okay, let us not take any current. Okay, I just think that the potential drop across this is V1. Okay, and potential drop across this is V2. Okay, now according to Kirchhoff's loop rule, the potential drop across a loop is 0. Or in other words, you can say the potential drop across all the resistors. Potential drop across all the resistors. Okay, if you take the sum of all of them, suppose V1 here plus V2, suppose this will be equal to the EMF of the circuit. Okay, EMF. So this is your loop rule. Okay, this is actually your loop rule. Okay, we'll just go to your book and we'll see the exact yes, we'll see the exact sentences what this book is saying. The algebraic sum of the changes in the potential around any closed loop involving resistors and cells in the loop is 0. Okay. In other words, as I wrote, if you see there may be many resistors in the circuit, and there may be one or more than one cells in the circuit in a loop. Okay. So if you find out the voltage drop across all the resistors and take a sum, okay, that will be equal to the sum of the EMF of the cells. Okay, I'll take few examples before I take that. Let me tell you what is this loop rule based on. This loop rule also based on certain law. This is actually law of conservation of energy. Okay, law of conservation of energy. So loop rule is based on conservation of energy. Energy. Okay, or in other words, we can prove from, see, if I have see here actually what is the driving force for the current or the charges to flow, that is electric field. And electric field, you know, this is actually conservative in nature, right? Conservative in nature. Conservative in nature. Conservative in nature. If you take a loop means it is cyclic path, right? It is a cyclic path. Suppose this is a loop. This is another. So this is a loop. This is cyclic path. If I start from A, then go all the way to B, C, and D, and come back to A. For any conservative force field, work done in a cyclic path, work done in a cyclic path is 0. For any conservative force, electric field is actually the driving force for moving the charges, right? Or in other words, see, you can define potential is actually work done per unit charge, right? and this potential actually depends on point to point on the circuit. See, potential here is not the same. Again, if you just come, see, go all the way, suppose I want to take all the potentials, see, at A, B, C, D, and come all the way here. So what is the work done over here? In a cyclic path, this is a cyclic path. So the work done will be 0 as you come to the initial point. Understand? This is the nature of the conservative force field. For a conservative force field, if you do certain work, suppose in this way, okay, suppose A to C, A to B, this is a point A, B, you go to this way, path 1, and do certain work, suppose W1, okay, and go in this path, okay, another path 2, suppose work done is W2. If this is a conservative force which is working from going from A to B, even if you go in a straight path, doesn't matter which path you follow, the work done is the same in all paths. So what is the on what this work done is depending? Work done is depending on the end points, okay, not the path. So look, in this case, the end point, if I start from here, A to suppose some point B, and then some point C, okay, then it come back to A. That means your both initial and final positions are the same point, okay. That's why the work done is 0 over here. So work done is 0. That means your potential. So work done per unit charge is actually defined as potential. So there will be no change in the potential at A. So VA minus VA, it is 0. So that's why in a loop, change in the potential will be 0. Okay. So this is what the basis for this loop rule. Okay. So we have understood there are two rules, junction rule. So in the junction rule, I'll just write in short. Junction rule, it is like I in, so which is going into, okay, if you just take the sum, that is equal to sum of the current going out of the junction, okay. And loop rule is saying if you have resistance and cells, many resistance, many resistors, many cells in a closed loop, if you take the potential drop across all the resistors, okay, or in fact potential drop in a closed loop, potential change in the potential in a closed loop is 0, or for our purpose, for when we'll be solving numerical problems, what we'll do, if I have many resistance, then I'll take, see, maybe potential drop across register 1, register 2, register 3, like that we'll take the sum. But while taking potential, so in this case, you know, like we have to see the sign also when we are taking some, whether this V1 is positive or V2 is positive or negative or whatever. I'll tell you while taking the example how to consider the signs, and this will be equal to the EMF of the batteries, okay. EMF, sum of the EMF of the batteries. If you have many batteries, then you can write on the right hand side sum of the EMF of the battery. In this case also, whether EMF you have to take positive or negative, that depends, okay. How positive and negative you can take, see, if you have a battery, okay, so this is the symbol of the EMF, sorry, a cell. So when you look, while you are going in a loop of the circuit, if the current is actually coming out from the positive terminal of the battery, then this EMF has to be taken as positive, okay. But look, if the current is actually flowing out from the negative side or negative terminal of the battery, then this EMF has to be taken negative, okay. We'll take up some examples and all these things we'll be addressing there. See, in each problem you have to apply junction rule as well as K. So this, see, in this second loop rule, here we are dealing with loop rule, we are dealing with voltages, right? So that's why voltages are potential. So that's why this law is given a name KVL, Kirchhoff voltage law. And this one is KCL because we deal with current over here. So Kirchhoff's law, KVL and KCL. So you have KVL and KCL, both the laws, and you have to apply this KVL and KCLs to solve numerical problems. Uh, and in fact, in your exam, there will be many in the board exam, or maybe whatever competitive exam you go, at least one problem you will get from Kirchhoff's law. Okay, so we'll just take a few examples. Okay, so this is a general example. Suppose I have uh, this circuit. So I have to, what I have to do, I have to apply KVL and KCL and find out, or I'll just write the KVL and KCL for this circuits. Okay, I'll write the KCL and KVL. How to write the KCL and KVL for this? Suppose KCL, how to write KCL? I'll just take the junctions. Okay, I'll just check the junction where the junctions are. So these are two junctions, right? These are two junctions. Okay, this is C and F. These are two junctions. So in this case, look, there are two batteries or two cells. This is E1 and E2. Okay, this, both the cells will be producing some current, right? They will be producing current. So whenever you have multiple cells or any cells, if the directions, current directions are not given, you have to apply your own KCL and solve the problem. Then my advice will be you to take always current out from the positive terminal of the battery. And suppose from cell E1, current I1 is flowing out, and from this current I2 is flowing out. Look here, it is coming all the way I1, and it is I2 here. So at the C point, it is meeting, right? They are all meeting. This I1 and I2, they are meeting at C. So they have to, so this is the only path through which they can come out. This is the only path which is CD. So through CD, what is the current then? See, I said whatever current enters, that has to go out or leave the junction. So this is the current which is entering the junction C. So that has to go out or leave. So what is the current I should write at this D? If I write I, this sum is equal to I. So I'll write this is I1 plus I2, which is going out from C to D. Okay, this part. I can write this as I. Okay, doesn't matter if I want to make make a simpler notations and all, I can just simply write I, which is I1 plus I2. Okay, so this I1 plus I2 goes all the way up to here, right? All the way up to here. Okay, and then when they come here at this junction, so this is coming up to here, up I1 plus I2. When, as soon as they come here, look, I have taken a current through this branch A to B is I1. So obviously this current will be I1 this way, and this current will be I2. So as soon as they cross this junction F, so this I1 plus I2, they gets divided into two currents again. So this C through F to C. Okay, F to C, this is I2, and from this FA all the way up to B, it will be I1. So this is how you have to apply your junction rules. Okay, you have to apply in this way. Okay, I hope you have understood what is junction rule and how to apply the junction rule. Okay, now I'll try to write the KVL. Okay, I'll write the KVL. KVL for the circuit. So KCL, actually KCL you don't have to write as such, but you have to, when you are analyzing the circuit, okay, when you are analyzing circuit, most of the cases you will be asked to find out what is the current through CD, suppose, or through R3. They will ask you what is the current through R3. then you have to find out I1 plus I2, which is flowing through R3. Okay. Sometimes they may ask you what is the potential drop across R R2 or R1 or R3. So these are the questions you have been asked. Actually, you will be asked in your question. What is the current through this branch, that branch? All those things they will ask. Okay, so this Kirchhoff's law, this current law is not enough to solve the problem, right? You have to see there are two unknowns. See, if they ask you to find out what is the current through, so this if the values of R1, R2, R3s are given and E1 and E2 are given, okay, if all the values are given and they ask you to find out the current, so there are two unknown quantities, I1 and I2, right? So if you have two unknown quantities in any equation or any problem, and you have to find out the value of those unknown quantities, then at least you need two equations. At least two equations are required. If more than that, that is all right. But at least two equations are required to solve the problem, right? So this is one equation, I is equal to I1 plus I2. This is one equation. Okay. The other equation you have to write, or maybe you just forget about this. This is extra equation. At least see, you can write two equations from this loop. Okay, KVL. Okay, you can write KVL, that means Kirchhoff voltage law, for these two closed loops. You look here, there are two loops over here. Okay, I'll just clean this portion. Two loops over here, two closed loops. If I start from suppose A, if I start from A, see, I can go up to, see, I can get loop 1 as A, go to B, then C, then F, then come to A. So this is a closed loop. I can get another closed loop L2, that is if I start from C, okay, I can go to C to D, D to E, E to F to C. Okay, this is another closed loop. So I have to actually mark the loops. Okay, while solving Kirchhoff's law, this kind of problem using Kirchhoff's rules or Kirchhoff's laws, you have to mark the loops for your convenience. Okay, so suppose I take one loop, so this is L1, which I am starting from where A to B and then coming all the way like this. Okay, I'm starting from, see, generally loops are, I'll just clean this portion here a little bit. Okay, so loops are denoted by arrow. Okay, so why this arrow like this? I'm just going from A to B, C, F and coming back. Okay, this is how. So like this loops are written. Okay, like this, like this. So see, the path you are following, the arrow will be in their direction. Okay, the path you are following. See, I'm following the path A to B, B to C, C to F, and then come back to A. Okay. Now look, I told that I have to write Kirchhoff's voltage law. How? You have to find out first what are the resistors in this loop and find out the voltage drop across all of them. Like that I told, right? So and at that time I told you that you have to find out whether this is plus or minus. So this voltage drop across any resistor, whether it is plus or minus. You might be thinking that I am listening first time. Yeah, you may be listening first time. This voltage drop is also positive and negative. This is valid for Kirchhoff's law. Okay. See how to find out whether a voltage drop across any resistor is positive or negative. That you have to see first which way you are going. Which way you are going. See, now I'm going from A to B to C to D, C to F to A. If I go in this way, look, I'll write KVL. See, for see A to B, when I go, I have this resistor R1. See, if I go A to B and the current also is going from A to B, that means the current direction and the direction of my loop is the same. In that case, the voltage will be positive. Okay. voltage drop across this will be positive. So what I'll write, so so I'll write for L1 loop 1. See, I'll write maybe here for L1. L1 means which one? A to B to C to F to A. This is a closed loop. I'll write for that. So I'm going from A to B. So I have a resistor R1 and I have current. See, I have current through this is I1. I have already taken I1 as the current flowing in this branch. Okay. So I'll write I1 into R1. Okay. Then I'm going to B to C. So there is no resistance. So there is no voltage drop over here. Okay. Then I go to C to F. When I go to C to F, what is the resistor I have? R2. I have resistor R2. And what is the current flowing through this? The current is I2. Okay. Look the direction of the current over here. The direction of the current is C to F, but I am moving towards C. I'm sorry. The direction of the current is F to C, but I am moving towards C to F. Okay, C to F. That means my current direction is opposite to the direction. See, look here. This is the loop direction, and this is the current direction. So these are two opposite directions. So I'll write here minus I2 into R2. Okay, in this loop, this is the voltage drop across the resistors. Now I'll look what is the cell on the right hand side. So only one cell is there. See, this is the E1. And in this cell, I told you have to check whether this is positive. You should check EMF is positive or negative. So that you have to check from which terminal the current is coming out. So in this case, look, the current is coming out from the positive terminal. So this I'll take as positive. So this is my KVL for this loop L1. Okay, this is KVL for loop L1 A B C. So when you are see these are the things where students actually get confused and they do a lot of mistakes. How to take the sign of this and how to take the sign of this. Okay, plus or minus, plus or minus. What is to be taken? Actually, this you have to understand properly. See, when you are choosing a loop, the direction of loop, and you have to check what is the direction of the current. If the direction of the loop and the direction of the current is same, then the potential drop, as I can see from here, I1 and R1, this is positive because my, see, I'm going from A to B, at the same time the current is also flowing through this R1 from A to B. So this is how I have taken this as positive. Okay. Now for the R2, look, the current is, what is the current through this? This is I2, which is flowing from F to C, but my loop direction is from C to F. So that's why I have taken this is as minus. Okay, I hope you are understanding. Okay, so this is how you have to take the sign. And see, for the cell, how I have taken positive. I told that if you're in the loop, while you are going through the loop in the cycle, so if the current is flowing through your positive terminal of the cell, then you have to take the EMF of the cell as positive. If reverse happens, that means current is flowing from negative side, that means it is going like this. Okay, then it has to be taken negative. So in this case, it was positive. Okay, so I could write this KVL properly. Now what I have to do, I'll be writing. Okay, I'll just clean it because this is very much messy. So I'll just clean this. Okay, this R3. Okay, so see, I'll take the other loop and write the KVL. So loop 2. This is loop 2. So you see, I am taking loop is from C to D. You can take clockwise, anti-clockwise, doesn't matter. Okay, that is up to you. But always remember that you have to take proper direction or proper sign of the voltages and the EMFs. Okay, so I am just going from C to D to E to F to C. That means like this. Okay, like this. So in this case, how many resistors are there? R3 and R2 are there. And how many cell is there? How many cells are there? So this is E2. So in this case also, look, I'll write from C to D, there is no voltage drop, so this is 0 because there is no resistance, voltage drop is 0. Okay. Now D to E, voltage drop is there because there is R3. What is the current flowing over here? I1 plus I2. So I have to write here I1 plus I2. So this is from Kirchhoff's current law. The current is actually I1 plus I2. Then I have to write R3. Current is flowing in the same direction as my loop direction is. That's why I have not taken negative. I have taken positive. Okay. Now another resistor is this one. So here, how much is the current? Current through this R2 is I2. And see the direction of the loop. I am going from C to A. F to C, and the current also flowing in that direction. So I'll be taking here positive. Okay. I'll take positive. I2 into R2. So these are the voltage drop across the resistors. And in the right hand side, I have to write the EMF of the cell. So what is the EMF of the cell here? So in this case also, see the current is coming out from the positive terminal of the battery. So I'll write simply this. So if you solve these two equations, then you will get the current values. If R1, R2, E1, E2 and R3 are given, then you will be able to solve what is the value of I1, because you have got already two equations and two unknown quantities are there. Then you can solve this problem and find out what is the value of I1 and what is the value of I2, and then in each branch you can find out the current. Okay, in each branch you will be able to find out the current. So this is how you have to apply the Kirchhoff's rule. Now I'll just want to take your feedback that do you people understand this? Has everyone understood or not? Nikhil, Priyadarshini, Kirtana, Savana, Shreya. Okay, Kirtana has responded by message that she had understood. Okay. So what about all others? Okay. Okay. Devika also said, yeah. So see, what I'll do, I have some examples. Okay. So all of you are saying that you have understood. I'm happy. You might have read also earlier, so that's why you could understand better. So now I have this problem, this example. Okay. So you people have to tell me what is the current through all the branches. Okay. What are the currents through all the branches? Okay. Can can you people? I'll just give you some, maybe some 3 to 5 minutes. Can you people solve this problem? See, I have two cells. This is 6 volt. This is 12 volt. This is 5 ohm resistance. This is 2 ohm. This is 3 ohm. You have to tell me what is the current through 5 ohm, through 2 ohm, and through 3 ohm. Okay. So there are three currents you have to find out. Okay. So current through all three branches. Can you people solve it? See, time starts now. I'll just give you 5 minutes. Okay. So now it is 6:50. So 6:55. I'll just ask all of you if you get the answer. Okay. So first of all, you have to write junction rule. Okay, junction rule, and get the current and current directions, etc. as I have done here. Okay. First I had done, and I had told you that if you have multiple batteries or no current direction is given, how to take the direction of the current and all. Okay. Then you have to write KVL. So I'll write KCL and KVL. So you have to write KCL and KVL. So first you have to write KCL. Okay, so that you can at least get write the current directions and various currents through branches, and then you have to write KVL. Okay. Can you people apply KCL and KVL both and find out current through this, current through this, current through this, all this way? Okay. See, in this while applying KVL and KCL, if you have taken wrong direction of current in the beginning, wrong direction of current does not matter. at the end, what you will get is you will get some current negative. Okay, at the end, when you will calculate the current, some current you will get negative. Then you have to tell that I have taken the opposite direction of the current, so current direction will be in the opposite way, and take the positive value of that. Okay, if you apply KCL in a wrong direction, doesn't matter, because in the answer you will get some minus current, but current cannot be minus anyway. So at the end of the result, so you can tell that the direction you have taken for the current, it is direction of the current will be opposite. In that way you can say. Okay, that is not a problem. Okay, but anyway, so guys, you can try, and then 6:55 I'll discuss the problem. Okay, how to do that. Are you people trying, or you are waiting for my discussion? Okay, so okay, so what I'll do, I'll just discuss here, and you people just see whether you are getting the same answer, or the way you are doing is correct or wrong. You can verify yourself. Okay, so I'll just remove this part. So I'll just give you a simple idea here in this problem, how to solve other problems also. You'll be able to get the idea from this example. So as I told you that when I have batteries and the current directions are not given, you take yourself current direction from positive side, and suppose from 12-volt battery I1 is flowing. So this will go all the way up to this B point. Okay, up to B point I1 is there. Okay, up to here, and I'll just take direction of current from 6-volt battery also in the upward direction. Suppose I2 is flowing, okay, from here, so I2 all the way that will go up to B point. Okay, B junction. So you know, junction rule you have to apply here at B. See, they are just coming and meeting over there, so they have to go out also, right? They will go out here. So I just take this as I1 plus I2. This is the current which is flowing through this. This is I1 plus I2. So when they come over here, they will get divided into two current again. This way it will be I2, and this way it will be I1. Okay, this is your junction rule. Very simple. So junction rule, after writing the junction rule, I have to decide the loops. So you have two quantities, I1 and I2, which you have to find out. If you find out I1 and I2, then I3 is this current through 2 ohm is I1 plus I2, so which you'll be able to get very easily. Okay, look, I'll just consider the two loops, loop this one, and another loop, this one. Okay, the two loops I'll be taking. This is L1 and this is L2. So L1, suppose it is going from, suppose F starts from F, or maybe I could start from A also, doesn't matter. So I'll start from F, F to A to B, B to E, and then come back to F. This is my loop L1. So here if I apply the loop rule or KVL, look, I have resistor 5 ohm, I have 2 ohm here in this circuit. Okay, so what is the current through 5 ohm? This is I1. Okay, I'm going in the direction of the current itself. Okay, see, the current direction and loop direction from E to A is the same. Okay, so this is that voltage drop across 5. So this, there will be no drop between A and B because there is no resistance. Now there is a resistance between B and E. So here there will be some drop. So what is the current through this junction, this branch? This branch, the current is I1 plus I2. So current is I1 plus I2, and what is the resistance over here? This is 2 ohm resistance, and see the direction of the current and the loop direction is the same. So I'll take this as 2 into I1 plus I2. Now there is no resistance further. Okay. Now I have to write the EMF of the cell. So how many batteries are there in this loop? In this loop, only one battery. And see the current I have taken from positive terminal. So you have to write S12 here. Now do little bit of simplification. So here 2 is there, right? And here 5. So you will get uh, yes. So you will get 7 I1 plus 2 I2 is equal to 12. Okay, seems to be a little bit odd equation, so you cannot reduce this. Okay, further. Okay, let it be. This is 1. I'll write the loop 2, KVL for loop 2. Let me denote the loop 2. Suppose I am going from D to C. Oh no, I have taken in, yeah. So D to C, I have taken, see the direction. I'll just remove some of the things here so that it becomes little bit clean. Okay. So anyway, I understand that B E branch there will be current I1 plus I2. So I am just going, suppose this way. Okay. C D to C, and then C to B, then B to E, and then come back to D. Okay. See, whenever I am taking a loop, I am not taking as I have taken here. I am taking opposite. You might be thinking, sir, we might have been taught, like you might have been taught either take clockwise or anti-clockwise. It doesn't matter. It depends on you. Okay. Only thing is you have to take the sign. So since my current direction is this way, I am taking the loop so that I don't have to bother about the sign. Okay. So that is the reason I have taken in this way. Okay. Now look, if I write the KVL for this L2, this is L2 loop 2. So I'll write 3 into I2 plus here 2 ohm. So 2 into I1 plus I2. So this is now all the way coming from here. So this is again, so there are no further resistance. So now the EMF is actually also here also it is positive because see current I have taken from positive terminal. So if you just do little bit of simplification here, see this I2 is 2, so you will get 5 I2 plus 2 I1. Okay, is equal to 6. Or you can write 2 I1 plus 5 I2 is equal to 6. This is equation 2. So if you solve these two equations, then you will be able to find out the value of the current I1 and I2. Let us do that. See, I'll write both the equations side by side. So this is 2 I1 plus 5 I2 is equal to 6. This is I2. So now if I have to just eliminate one of them. So what I'll do, I'll just eliminate I2. So I can multiply here 5, here 2. Okay, and then just uh, do subtraction. So if I multiply here 2, this will be 4, and this 5 means this is 35 I1 and plus 10 I2 is equal to 60 over here. Okay, now here it is actually this is 4 I1, this is plus 10 I2, and this is 12. Okay. So if I just do the subtraction, see this I2 goes off, and here so it will be 31 I1 is equal to this is 12, 60 minus 12, so it will be somewhat, I think, something like uh okay, just let me see. I'm just multiplying, this is okay, 60, this is my yeah, this is all right, this is 48. So what is the value value of I1 is actually 48 by 31. Okay, so now if you do the elimination of the other one, or maybe you just substitute in any equation this value, so I2 you will be able to get 18 by 31. Okay, so these are the value you have got. Now if you just add both of them, what you get is the I3, which is flowing through this 2 ohm resistance, will be I1 plus I2. That means your this will be I, or I3 will be 66 by 31. Okay, so this is the answer. So I had taken a simple example to show you how to write the KVL and KCL and solve the problem. But there may be many complicated problem like this. Okay, many other complicated problems. In fact, I had many examples, but time did not permit. So I had many examples to do. What I'll do, I'll just send you few problems in the WhatsApp group. If you people are not there, you just try to be in that group. Already some people are there in the group, so they can see I had already sent some problem in the last based on the last class. I'll send few more problems and then we'll discuss in the next class. Okay, so if you have any doubt, you can ask me. I'll give you some 2-3 minutes, then we'll stop the class. I'll send you some problems in WhatsApp group, and I'll just write uh, my WhatsApp number if anybody wants to join our this group. Okay, so this is my WhatsApp number. You can see in the chat box. So if you people want to get connected to WhatsApp group, then please send me a request message. I'll add you people there, and we can uh, like solve many problems through WhatsApp also. Because see, we may not be able to solve many problems in 1 hour. Okay, what I'll do, I'll solve at least one problem and discuss other problems in WhatsApp group. If you will have to solve by yourself and upload in the group whether you are doing correct or wrong or whatever, I'll discuss over there. Okay, so today so this is all for today's class. So anybody has any question? Kirtana, you have any doubt, question, or any queries?
No, sir. If I have, I will post in the group.
Sure. Okay, what about others? Nikhil, Priyadarshini? If people are not asking any questions, I'll take an exam, a surprise exam for all of you. I'll see how you people are understanding. Okay, based on CBSE standard, I'll take an exam. Okay, let me finish this chapter, then I'll set up a question and post in WhatsApp group. You people have to answer and send me the answer sheet. Okay, that I'll do very soon, just after finishing this third chapter. Before entering to the fourth chapter, we'll be discussing various problems, okay, or conceptual questions which are being asked in previous papers in CBSE board or maybe many competitive exams. We'll thoroughly discuss, at least 1 or 2 class we'll discuss, and then we'll move forward for the fourth chapter. Okay. Okay, so I think Shreya and Ayesha, they are new to us. Okay, so new. I don't know like what you people are doing, whether you people already graduated, like HS already you have done, or you are aspiring for 12th standard like HS exam or something. If people can write like what standard you want to get or something. Okay, so just do one thing. You people write in the WhatsApp. Okay, WhatsApp group further if you have any query and question. I'll stop the class here. Okay. Okay, bye. See you on next I think Sunday. Yeah.